Hi, I'm Chris Maddock, designer of the Harmony House.
Good morning.
Hi there. Just cleaning up a little around the place.
I'm Bob Douglas with Mitsubishi.
Pleasure.
So the place is moving forward?
We're looking at about 2 weeks. We should be about done.
Great, great.
Yeah.
Well, I'm here to see if we're ready to put in the heating system. I wanted to get a quick tour before we actually put a crew on site. So,
Excellent. I can show you right now where we're going to be setting it up. If
Alrighty.
you follow me, I'll show you where it is.
Super, thank you.
Yeah, come on, it's down this way. So Bob, these are the slabs where the Mitsubishi Zuba heat pumps are going to be sitting. Are they going to be all right? Is this?
Yep, no, they look fine. See, you've got the 2-inch hole there to allow the refrigerant lines to go in, and wires are run in, so no, everything looks good.
Now, in the house that I just had previous to this, the neighbor just put in a heat pump, and it caused me a lot of stress. It was quite noisy, and I really couldn't enjoy my backyard. Now, I understand your heat pumps are ultra quiet.
Yes, they are. The technologies used in the heat pumps have advanced a long way from those original units that were used some years back.
Right.
And you'll find that the Mitsubishi heat pumps are so quiet that you actually have to look at them and see the fan turning in order to know that they're on. You can sit right beside them, entertain out on your deck, and they won't present any kind of a problem at all from a noise standpoint.
So I don't know anything about heat pumps. Can you explain a little bit how this actually works?
Yes, I can, Les. One of the unique sources of energy that we'll be using in the Harmony House is the embedded energy that exists in our outdoor air. An air source heat pump is really just an energy mover. We'll be using it to extract heat from the outside ambient air and move it into the house.
Really?
Yes, in fact, the system can be used to both heat and cool a home. In the summertime, we'll be taking the heat from inside your home and moving it outside. And in the wintertime, we're going to do the reverse. We'll take the heat from the outside air and move it inside the home.
Well, this is where I don't understand. How, in the wintertime, is there enough heat in the winter air to actually heat our home?
Absolutely. I get that question all the time. People say, whoa, wait a minute. How are you going to take heat from minus 20-degree air and move it inside my house? The answer is quite simple if you understand the thermodynamic principles behind this technology.
Unlike a furnace that creates heat, an air source heat pump simply moves it from one place to another, like a refrigerator. So while the term may be new, the concept isn't. An air source heat pump simply takes heat from outside to warm the air inside the home. In the summer, the direction of the heat flow can be reversed to cool your home. The beauty of this technology is that through the refrigeration cycle, a heat pump uses 1 unit of electrical energy to provide 2, 3, or even more units of heat in return. Ask your heating contractor for a heat pump that's fully variable. They're not only efficient and quiet, but they also ensure you receive just the right amount of heat to keep you comfortable.
Whoa, a lot warmer in here, Les. Wow, what a beautiful home. It's really coming along. Holy mackerel, and look at this wall.
Yeah, we just got this. It's a feature wall, and just done this past week. And actually, the stairs are going to be putting in these stairs this week.
Excellent, excellent. That's hemlock.
This is hemlock, and the stairs are actually Douglas fir.
Excellent, excellent.
Cabinets are coming in next week as well, so there's a lot of things happening.
Super.
Now, back to Mitsubishi heat pumps. Can you tell me a little bit about how these actually work?
You sure can. The first concept in understanding a heat pump technology is best explained by looking kind of at the universe at large. We've actually just recently done a video on this that I could let you have a look at, and you can see overall how the concept works.
All right.
Let's talk a little bit about the universal laws of energy. The first concept in understanding a heat pump technology is best explained by looking at the universe at large. In space, we find the average temperature is minus 270 degrees C. That's about 3 degrees above absolute zero. Absolute zero is minus 273 degrees C, the coldest known temperature in the universe. And anything above this temperature has to have both matter and energy. Temperature variations also exist in space, as it is occupied by objects having different matter or mass and energy. Objects range in size from ultra-small particles like photons to larger than our sun and include things like planets and even closer to home, our moon. Much of the moderation and variation in temperature we experience on our planet can be explained as the difference between a planet with an atmosphere as compared to a planet without one. The reason being, the atmosphere reflects some energy, keeping us shielded from the intense energy from the sun, while at the same time acting like an insulation that keeps radiated heat energy inside the atmospheric blanket, keeping us warm. The atmosphere also functions to spread energy more evenly across its surface, giving us an average temperature worldwide of around 15 degrees Celsius. It's important to note that this is 288 degrees Celsius warmer than absolute zero. And this substantial variation provides an opportunity for redistribution or movement of energy, or heat. Heat pumps are a very efficient method of moving heat from one place to another. Typically in summer, we want to move heat outdoors, and the heat pump does just that. For 1 kilowatt of energy that we put into a heat pump, it will move 3 kilowatts of energy or heat outside. In winter, we want to move energy as well. Only this time we want to move energy or heat from outdoors into our homes. Remember, minus 20 degree air is still 253 degrees Celsius above absolute zero, and that means it contains a lot of energy. Our heat pump technology can extract this energy and move it into our homes. All this extracted heat is delivered via ductwork, similar to the traditional forced air furnace.
Okay, I'm sold, Bob. That's amazing. So these things are really, really efficient.
Yes, yeah, they're really highly efficient units. The heat pump will take about 1 kilowatt of energy, as the video said, and it'll move approximately 3 kilowatts of heat into your home. So say compared to a baseboard heater, your energy bill would be about a third of what a baseboard heater would take. So
That I like.
yeah, I'm sure you do.
Anyway, so this is absolutely tremendous. I'm so happy to have Mitsubishi as part of our Harmony House project. This is just the most fantastic thing.
Part of the team.
Thank you.
Hi, my name's Richard Parkinson from Mitsubishi Electric. We're partway through the installation of the 2 systems at Harmony House. The first system, the one to my left, consists of an air handling unit and an air source heat pump. This heating and cooling from the air source heat pump is what provides the heating and cooling for the entire house. It is transmitted through the house through this ductwork, as we can see, installed onto the air handling unit.
Okay, I'm Cody. I'm working for Stoltz Mechanical, doing all the HVAC here. The main thing that heats and cools the whole house is this air handler here by Mitsubishi. It's 100% variable speed because in this building we got 2 different heat and cooling loads. And so there's a variable volume system with the zone dampers you see here. So those will be wired into a panel. And so this there's a controller that will decide which space needs heat or which space needs cooling depending on the load and the thermostat, the zone sensor in the space. So yesterday I ran the refrigerant lines that go to the outdoor unit. And this is what pumps the refrigerant in and out of the coil. And actually the same refrigerant heats and cools depending on what mode the outdoor unit is in. These are all the fancy controls for the variable speed and the indoor-outdoor unit. So everything's all on communication wires instead of your traditional system, which is just on-off control. So it's all 100% variable. And the hot water for the building is all supplied by a similar outdoor unit, but it goes into the mechanical room to a heat exchanger that instead of cooling or heating the air, it heats the water instead. So in the mechanical room, we have the box inside there, which I'm piping today. That's this unit here. This unit, I got one pipe on here so far. This unit here will provide the hot water for the house, which is also supplied by a Mitsubishi unit that's 100% variable. So depending on the heating load for the house, how many taps or showers are running, decides how much capacity is needed. So like a traditional hot water tank is always 100% capacity, regardless of the load or how many taps are being used. This one will modulate accordingly. So the refrigerant lines here, similar to the air handler, they go outside to an outdoor unit, and then the cold water in, cold water out, in and out, go here, and it'll be pumped or piped to a pump to this holding tank that has a heat exchanger in it for all your domestic hot water. So it's not it's a combination of an on-demand system, and you still have storage tanks. So if there's any of those huge demands, if you have 4 people having a shower and you got the washer or dryer running, this will be able to withstand the load.
The primary hot water system is a solar system, which is from this tank here. If the solar system cannot maintain heating, then this backup system provides hot water through this heat exchanger, which is then fed to this secondary tank. This secondary system will only come into effect if the solar system is unable, or if there is no sun, to provide the hot water sufficient for the house. This heat exchanger refrigerant pipework is installed along the ceiling and is then punched through the wall to go to the outside air source heat pump. I'll now take you back and show you where this pipework runs to. As you can see, the pipework runs down inside of the mechanical room to the end and is almost finished. We're just in the process of doing the final connections to the outdoor condenser unit. Once this is done, we can pressure test and commission the system and then start capturing the heat from outside to produce hot water.